Hi, and welcome to my YouTube channel. My name is Juan Martinez. I am a data analyst. In this video, I'm gonna show to you how to make data analysis on the Bellabeat case study. This is a project for the Google Data Analytics Professional Certificate. So I'm going to walk through step by step my own analysis when I did the professional certificate. So without further ado, let's do it. Okay, so first of all, I'm going to find the data set, which is on Kaggle. So here on Kaggle, I'm gonna just type Bellabeat. And if you are doing the certificate, you can find where the data sets are. So in this case, I'm gonna choose this, and here we can see information, or we can read information about the dataset. So this dataset is about a fitness tracker. It's data from a fitness tracker. So here it says it's generated by respondents to a distributed survey via Amazon, and so we have some more information, and we have data about for example, here I can show you. So it's basically data from this kind of devices. So this is like a smartwatch. Okay, so it's data that is stored here. So it can be the heartbeat, the calories. So these smartwatches can track a lot of data about our health, the hours we sleep, a lot of things. So we are going to analyze that, and we can see here all the data sets. These are in CSV. These are CSV files, and we can use all of this for our data. You can download each and every one of these data sets, of these files, or you can use them so that you can use them on your own, on your local computer. Maybe using you can make the analysis on the on a Jupyter notebooks, or on Google Colab, or with Excel or SQL, or you can use it right here. So if we want to use it here, we can click the button New Notebook. So this is going to open a new notebook, a new Python environment. I'm going to do this on Python, and we can begin our analysis. So first of all, here we have some libraries like NumPy and Pandas, and also here we have the directory where the files are stored. So we just need to run this block of code, and it's gonna show us where exactly the files are. So we can see that it's on the Kaggle. All of this, the advantage of working on Kaggle is that all the files and everything is on the cloud. So we don't have to save anything on our computer. It's on the Kaggle file, Kaggle folder, input folder, Fitbit folder, base folder, and this is the file name. Okay, so after that, we first need to understand what the purpose of the analysis is going to be. What's the goal? What the stakeholders are asking for. So in this case, we want to, okay, we know already what the dataset is about. So for example, we can see here that it's tracking calories minute by minute, the weight, information about sleeping, intensity of exercise, I can imagine, calories on a daily basis, number of calories burned on an hourly basis, the heart rate, the minutes of sleep, etc. Also the steps, daily steps given or taken. I don't know what to say. how to say it. Okay, so the business task here is to understand the users, how the users use the smart devices, so that Bellabeat, this company, can make a marketing strategy or can work on a marketing strategy. So our work is to give them insights about how the users are using the device, these smartwatches. But so let's begin. We know the business task. Now we have to prepare the data. So we have to take a look at the data itself. First of all, we need to import it. So before importing the data, I'm just going to prepare my environment. So I'm going to import some libraries. We already have pandas and numpy right here, but I'm just going to import them again, so that we have it here. Import numpy as np, import pandas as pd. Also, I'm going to use matplotlib for making graphs, and I'm going to import seaborn for also plotting. And I'm going to use a style for my graphs. So on matplotlib we have different styles. I'm going to use the ggplot style, and I'm going to set an option to be able to see all the columns. So it's set option max column. Okay, but first I'm going to just comment on this, and I'll see if I need it later. Okay, so I'm going to run this. Okay, I had an error here, misspelling. Okay, so I imported the libraries. Then I need to import the data. So we have to import the data. First of all, we have to see what we want to analyze, because it is a lot of files, and we only want to specify. Only we can analyze the calories, or the sleeping patterns, or the heart rate, or the steps. So we have to make sure of what we want to analyze. If we want to analyze everything, it's going to take a lot of time. So in this case, I'm going to just import the daily activity merge, which is this file contains information about everything: calories, steps, hours of sleep, intensity, everything. So it's merged on a daily basis. So we don't have to be aware or worry about each hour or each minute. So to import our dataset, I'm going to create a new variable, which is going to be df, which is or stands for data frame. I'm going to use the read CSV function, and I just need to copy and paste the path of our file. I'm going to read this, and now we have to begin by exploring the data. So I'm going to explore the data, okay, with df.shape. The shape we have 940 rows and 15 columns. Okay, we know that. Okay, so now let's see what are the name of the columns. So with dot columns, we can see the name of the columns. We have ID, activity date, total steps, total distance, tracker distance, logged activities distance, and so on. Okay, we already know the name of the columns. We have a idea, but now let's see. Let's take a look. What is the information inside those columns? So first of all, we can show a preview of the data with the head function. So I'm just going to show that the first 10 rows. Okay, so we have here the first 10 rows of data. Okay, we know ID is like a number, activity date, a date, total steps, a number, the steps given, distance, minutes, and we have also calories. Okay, we have to take a look of the data, just a quick peek, and we need to understand what the columns are about. So for example, logged activities distance, we can infer, or if we are working on a company and we are part of the team, we can ask, for example, if we didn't create the dataset, we can ask what the columns are about, what the information means, so that we can work better. So some of these are self-explanatory, some are not so much. For example, logged activities distance is the distance tracked by the device on specific activities. So we have to decide which of these columns are going to use for our analysis. Okay, so now after this, we need to know what the data types are for each column. So for that, I'm going to use df.dtypes. Okay, so we already see here what the data types are. For example, ID, it says here that it's an integer, a number, which is incorrect because it has to be a string. Maybe it was stored as a number, but if we store it as a number, Pandas or Python is going to make calculations if we want to, I don't know, sum or multiply. But with ID, we don't want to multiply it or making sums or subtraction or something like that, because ID is just a number to identify each row. Okay, it's an identification number. And most some IDs don't have even numbers, or they have letters, or some have letter and numbers. So we need to fix this. So now, okay, so here I'm going to say this is the first phase, prepare the data. So now we have to clean the data. Okay, we already know some of the data. We took a look at the data types, etc. So for example, also activity date is an object and it has to be a date in a date format. So we have to change that as well. Okay, so now I'm going to the next step, which is clean the data. Okay, so first of all, we can begin by reformatting these columns. So we said that ID has to be a string. In this case, so for that I'm going to make this df and square brackets ID equals df, which is the name of our dataset, and inside the square brackets we have to specify the name of the column to call it, and we are going to use the function as type. str stands for a string. So with that we can transform this column, all the information, all the rows, to strings or to a string format. Also we want to change the date, we said. So the date is activity date. from object, which is the same as a string, to date. So in this case, I'm going to use the following function. Okay, to date time function, and I need to specify what I want to transform. So I want to transform the activity date column to date time, and also I need to specify, or I can specify the format of the date. So in this case, it's going to be, first I want the month, because we have here first the month, the day, and the year. So I want the month first, the day next, and oops, okay, I'm making an error here. I don't have to. Okay, I'm going to sum this so that you can see what I'm typing. Okay, so I need to do this and the year. So for the year, we have this. Okay, and after reformatting, I'm going to check the D types to make sure we did it correctly. Okay, so now we have ID as an object. It's different from here. And I also have activity date as date time. Okay, everything else seems normal so far. Calories are numbers, minutes numbers, and these are floats, which are decimals. Okay, because it's tracking distance. Okay, so far so good. Now we have to check for null values. This is another thing we have to do. So, but first, before doing that, I'm going to check the values inside our columns. So what I'm seeing here is that, for example, the total distance, where is it? Yeah, total distance, it's the same as tracker distance, but why repeating the columns? It doesn't make sense. So it's related, but we are not sure. Maybe these are not the same. Maybe it's a combination of these other columns: logged activities, very active distance, moderately active distance. So what I'm seeing here is that we have here zeros on the logged activities distance column. So maybe all the sum is for example, when we are summing very active, moderately active, or light active, and sedentary active, and all of that, maybe the sum of that equals the tracker distance. And if we sum the logged activities distance column, which in this case, in these first 10 rows is 0, maybe it's gonna give us this, but we don't know. So what about we check that? So now to check that, we can make another, we can do something. Maybe we can create a new column and sum all of this, or we can subtract these columns, and the result, if it's the same, has to be 0 all the time. So I'm going to create a new column. So in this case, I'm going to do the following. I'm going to create a new column, which is distance diff, because we want to know the difference between these two columns, the total distance, the tracker distance. And so that's going to be equals to total distance, minus the F tracker distance. Okay, so let's do it. Okay, so we have run our block of code. So now we have to check. So our first rows are going to be 0, but I want to see if there is another values, or if there are another values or more values other than 0. So for doing that, maybe I can count the values. So this is value counts. This is a function. Okay, so yeah, so most of the values are 0, but we can see that there are some columns where there is a difference between total distance and tracker distance. So in one row, because it says here only 1, the difference is 1.83, and other is 0.19, and etc, etc. So okay, so we know that. So let's check what's the actual difference between those. So for doing that, we can use the following, which is query, and okay, so I'm going to use distance diff equals 1.830000. Okay, so let's see. Okay, we don't have any. Okay, maybe I'm doing it wrong. Distance diff. Okay, we don't have any. Okay, what about zeros? 0.0. Okay, yeah, it's showing us here the distance diff. Okay, maybe we can specify it's greater than 0. Okay, yeah, so we have here the rows where there is a difference between total distance and tracker distance. So we can see already here 9.71 on total distance and 7.88 on tracker distance. Okay, so if we make a further inspection, okay, I'm going to zoom out a little bit so that we can see. Okay, yeah, we can see that here we have some values, logged activities distance. Okay, and that didn't appear where it equal to 0. Oh, you can see, so here we have 0 on logged activities distance, and when it is greater than 0, we have some values here. Okay, so that shows us that these two columns are not the same. Even though it appears at first glance that it's the same, it is not. So we have our answer right there, and you can also see that the difference is not this column. The difference is in this, for example, on the first row is 1.83. So maybe it has to do with this, but it can also be that, for example, this column, maybe also this has to has an impact. We don't know, but we are not going to focus on that. And so I just want to show you what we can do if we find, for example, two columns that store kind of the same or similar data. And in this case, you can make use of these functions to make sure that if those columns are store the same data or not. So if they are the same, so you can delete one of those, or maybe it was an error from the developers, the data engineers, or the people who created the data. Okay, so now we can dig deeper, but we are not going to focus on this. Now we are going to rename the columns. So we can see that it has an uppercase first letter for every word. But for simplicity, I want and I like the columns to be in lowercase. So to do that, we can transform our columns with the following. In this case is the f.columns equals the f.columns dot string. So we are accessing the string functions dot lower. Okay, so now this is going to show us the columns in lowercase. So you can see we have transformed them on lowercase, but it can be confusing. So what we like to do, and it's a very common practice among data analysts, is to separate words by using an underscore. So for doing that, or to do that, we can rename our columns with the function rename. So I'm going to rename all the columns. And to do this, I can just copy and paste all the name of the columns. But first, it has to be inside brackets, because it's kind of a dictionary. So ID, so it's going to function like a dictionary. So ID, I'm going to transform. Okay, I don't want to transform ID because it's already fine. I want to transform, for example, activity date from that to activity underscore date. Total steps into total underscore steps. Total distance into total underscore distance, and you get the idea. Okay, maybe I'm going to speed up this process so that it doesn't take too long. So hold on a little bit. I'm just going to copy paste this. Logged activities distance. Very active distance is going to turn into very underscore active underscore distance. Moderately active distance is going to turn into moderately active distance. Like active distance. Sedentary underscore active underscore distance. very underscore active underscore minutes, fairly underscore active, active underscore minutes, lightly active minutes. It's going to be lightly underscore active underscore minutes, and sedentary minutes is going to be sedentary underscore minutes, and calories, I'm not going to change this, the instance diff. Okay, and I also want to make the following. It's going to be in place equals true. So by placing in place equals true is going to change the name of the columns for real. So maybe we can first make it false just to check if everything is okay, if everything is fine. So we can see here that there is an error. Okay, there is a valid syntax. Oh, I know why. Because this has to be outside the brackets. Okay, what's going on? Okay, maybe it's because I need to place everything together. Oh yeah, because I need to delete this. In the difference, I don't want the difference. So now, yeah. So it's false, so we can double check if everything looks fine. Total distance, tracker distance, sedentary active distance, calories. Okay, so if everything is correct, we can change and turn it to true. So also here we can see the name of the columns. Okay, looks fine. And okay, now I just want to, let's create a column. So we can add a column to tell us the day of the week using the datetime function. In this case, the function is day underscore name and parentheses. And we can also add another column with the number of the day of the week using the function weekday. So in this case, I'm going to create those columns. So I'm going to just right here create columns. So this new column is going to be day of week, which is going to be the activity date, and we have to transform it with the datetime function. So I'm going to just check if we have the datetime. Okay, I don't. Maybe it's, I'm going to import it. Import datetime as dt. Okay, so after doing that, I'm able to do this day name. And also I want to create the number of the day of the week. Okay, so I created here a variable. Now I need to create the column itself. So it's going to be called day of week, and it's going to be equal to this variable. And I need to create also the number of the day of the week so that we can use it later for our analysis. So I'm going to call it n underscore day underscore of underscore week. So this is going to be equal to the activity date dot dt dot weekday. Okay, so weekday is going to be our function. And also, just to quick reminder, 0 is going to be Sunday, or sorry, it's going to be Monday, and number 6 is going to be Sunday. Okay, but you can change that. You can change that if you want the number 1 to be Sunday, because in some places they like to begin the week on Sunday. I don't know who do that, but yeah. So now we have this, and now we can check if everything is correct with the head function. I'm just going to see the first 4 columns. Oh, sorry, the first 4 rows. And here it says Tuesday for the first date, and it's the number 1, the day number 1. So we said 0 is Monday, 1 is Tuesday. So everything seems fine. Okay, so let's move on. Now we can check for empty values. We can check empty values or null values. So checking null values. So for this, I can use the following. The f dot is na dot sum, because if we only use na, it's going to return a series of a Boolean series, and every row is going to check or tell us if it's false or true. So you can see here, like for every row we see the information false, false, false. So we don't have any null values here or here or here or here or here. But I just want, this is all for all the 940 rows, but I want to see the sum of it. Okay, so we have here every column and a number. So here it's going to be the number of null values, so we don't have any, it seems. We can also use the is null function, which is kind of the same function. You can use both, and is NA or is null, it doesn't matter. Also, we want to check the number of duplicates. So I'm going to write here a comment checking duplicates. Okay, for duplicates we can use duplicated, the function, and also that's sum. Okay, so in this case it shows 0. Okay, we have the number 0 here, so it means that we don't have any duplicates in our data, so that's good. And duplicates it's not telling us for each column. So there could be, for example, I don't know, Monday. It's obviously that it's duplicated because there could be many Mondays, but this function shows us by row. If an entire row is duplicated or has a duplicate with the exact same information in another part of our data. But here we don't have any duplicates about that so far. Okay, so now let's subset the data, because I just want to use specific columns. I don't want to use all the columns for our analysis. So, for example, if we see the data, we can see something. For example, total distance or tracker distance or any distance at all. It doesn't say if it's miles, if it's kilometers. It doesn't say. And okay, with minutes we don't have that problem, because we know that it's, for example, in this case 25 minutes. But for the distance, we don't know. We don't know if it's like I said, miles, feet, kilometers, meters. We don't know. So for that, I'm not going to use the distance columns. And also, distance is highly correlated to steps, because these smartwatches are tracking our steps, or the steps of the subjects of the population, and also it's supposed to equals like more steps equals more distance. We can also check that, but we can already see here, for example, 13,000 equals 8.5, and 10,000 steps equals 6.97, and 10,400 6.74. So you can see the correlation here. So maybe it's not necessary to keep the distance, because the steps also tell us the distance. The more steps given or taken, the more distance the subject or this person did or traveled. Okay, so for subsetting the data, I'm just going to, we can either create another variable. So in this case, you can say df sub, okay, to differentiate that between our original data frame and this subset of the data frame. It's a good practice to separate them. Or if you are already conscious, and if you are sure that you don't want to use at all some columns, okay, you can either delete them, which is not, if you're only reading the data, it's fine. But if you are working with the original data, it's not a good recommendation to do. Or you can also subset the data, like we are going to do here. Okay, so for that, I'm going to do this, and I'm just going to select the columns I want to use. So for that, I'm just going to copy and paste the name of the columns I have here, and here we can either delete or just comment the columns we don't want. So we don't want anything related to distance. Also, we don't want the distance difference. And yeah, and that's all. So I'm just going to do this. Okay, maybe I can just delete this. And also I want make this a copy of our data. Okay, I'm just going to, for simplicity, I'm just going to call it df again. And if I want to see these columns again, I can come back to this block of code, and maybe create another subset of the data. But in this case, I'm sure that I'm not going to use these columns at all. So I'm just going to run this code, and now we can see, if we just type df, or the name of our dataset, we can see. Okay, let me just use head instead, so that I can move here. Okay, so now I can see only the columns that I want to use for my analysis: the ID, the activity date, total steps, total distance, very active minutes, okay, all the minutes, and the calories. So we can also create total minutes. That could be awesome. But first, let's create some categories. So now we're entering the analysis phase. It's not just the cleaning phase. The cleaning, it's going to take us a lot of time. We only did like a very rudimentary cleaning phase. But for my analysis, or for our analysis, just a reminder not to copy or not to post my analysis and as your own on Kaggle or whatever place. Only use the information here, and also your creativity to make your own analysis. So now I'm going to create a category of the users, okay, because we want to analyze the users, okay, the information, their information, the patterns, and their actions. So I can create a category of the physical activity. For example, I can make, I just want to write here. Okay, we can say a user is sedentary, okay, or not active, if the daily steps are 6,000 on average, okay, or less. Oh, let's just say less than 6,000 on average, and it's active if it has between 6,000 steps and 12,000, and very active if it has more than 12,000 steps daily on average. Okay, everything is going to be on average, because on a given day, one user can make less than 6,000 steps, and another day you can make more than 12,000. So on average, if that person did, for example, I don't know, 7,000 steps, it's active. Okay, it's considered as an active user, or a physical active user. Okay, so that's going to be one of our categories. Okay, our second category is going to be about the use of the device. So for example, we can see we can sum the minutes, how many minutes it was using the device. And for example, we can see here that it did, in this particular day, this user it was 25 minutes being very active, 13 minutes being fairly active, 328 being lightly active, and 728 being sedentary. Okay, we don't know exactly what very active means. Okay, what's the meaning exactly? What is the specification of being very active? Like running, I don't know, at a certain speed, or walking at a certain speed, or burning some kind of, or some amount of calories per minute or per hour. We don't know. We don't know that information. The same with fairly active, lightly active. But instead we can use the minutes to see if the person was using device or not, and how much, or for how many hours. Okay, so our second category is going to be low use. So in this case, the person used the device less than 8 hours per day. Okay, this is going to be also an average. A normal use, okay, between 8 and 16 hours per day. And high use, which is more than 16 hours and up to 24 hours. Okay, so why we are creating these two categories? Okay, maybe we can think that someone who used the device more than 16 hours, which use the device very often and for long, it's a very active person. But maybe the data tell us different, that maybe the people who use the device or wear these kind of smartwatches all day long maybe are not so active, and maybe they are sedentary people. And maybe those who use the device not so often use it for only exercise, when they exercise, and they are very active physically. But we don't know. We don't know the answer of maybe this is a question our stakeholders ask us. So we are asking this ourselves to see and to make our analysis. It's a great way to practice. Okay, so first I'm going to group the data by activity level. So in this case, I'm going to create a group by ID. Okay, so I'm going to group. Okay, also let's check how many values do we have? Oh, this is maybe unique. Oh yeah, so we have okay, so we have 1, 2, 3, 4 times 1, 2, 3, 4, 5, 6, 7, 8. 4 times 8, that's how much? 32 and 33. Okay, we have 33 people. And so I'm going to create now. Okay, now we know how many people were analyzed, or how many people were being tracked, whose data was tracked. So now I'm going to create the groups. So for this, I'm going to use the group by function, and I want to specify which column. Okay, so I'm going to group by ID, and now I'm going to look for the average amount of steps and sort the results in descending order. So this is going to give me the average for each one of these IDs. Okay, so I'm going to have only 33 rows for each row for each ID or for each user, and I want to find the average or the mean of the total steps. Okay, because some people are going to we have entries for each ID multiple times, because for example, if I want to know for how many days it spans here the data, value counts. Okay, what's wrong? Count values. I always confuse myself. Count values. Okay, so what was the value counts? It's so confusing. Value. It's broken English. Value counts. Oh, yeah, I was correct one time, but I just wrote activity date wrong. Okay, so the max is 33. So we have from 2016, from April up to May the 12th. April 12th until May 12th. Okay, so this data is for only 1 month, which is not so good, but okay. So now I'm going to create the oops, I just deleted the grouping. Yeah, I have it here. Now I'm going to take a look at the average step. So this is the ID group, and I want total steps, and I want the mean of that, and I also want to sort the values in descending order. So I'm going to write ascending equals false, and this is going to give me the mean of this. So after that, I need to turn this into a data frame. So ID average step equals ID average step to frame. This is going to be the function to create this. And now we can see our results. So this is going to be like a different data frame, a separate one, which groups the information by ID. Okay, so we can see here the ID. This is the identification number for each user and the mean of the total steps. So this is going to it's a sum of all the steps on the total steps column divided by the times this ID it appears. So we can see here this information. Okay, so now I want to create a column which is going to tell us in which category this particular user fits in. So we know we have the data, the number here, but we want to know if it's sedentary or active or very active. And instead of just looking at the numbers and say, okay, this person has more than 12,000 because it's 16,000. Okay, so this is very active. We can create a column and state in which category this person is. Okay, so for that I need to make some conditions. So for doing that, to do that, I need to create first conditions equals, and I want to type the conditions to create each category. Okay, so if this column is greater, it was less, okay, less than 6,000 steps, okay, it's going to be sedentary. And the other is if the steps are more than 6,000 and less than 12,000, let's say, okay, I'm just going to use less or equal, because what if someone has 6,000 exactly? It's going to be another condition, and the last condition is for the very active users, which is ID average step. Okay, here I have this is greater or equal to 12,000. So we have now here our conditions. So for the first condition, the value is going to be sedentary. Okay, the second value is going to be active, and for the third condition is going to be very active. And now I need to create the column, the ID average step, and the column is going to be named activity level. And to create a column, I need to use the select function on NumPy, which is going to select the conditions and also the values. Okay, so this is going to, with these conditions, is going to create these values on this column. So now I'm going to store these results on a variable to use it next. So I'm going to create ID activity level equals ID average step and activity level. Okay, so with this I'm just storing the column on a variable because I just need to this is going to create something like this. This is going to show us here another column, and it's going to say active, very active, sedentary, etc. So for example, let's just show you what this looks like. Okay, so this is what we have done. Okay, so we have the ID, the total steps, and the activity level. So you can see here this person or this user has more than 12,000 steps on average. So it's a very active user. And this one has less than 12,000, so it's active. And we have we can see it's less than 6,000 steps. So it's considered a sedentary user. And yeah, so this is the information. But now I want to replace this. Okay, we want this column with this information on our original data set. Okay, and we have here the activity level for each ID, but I want to make a replacement. So for that, sorry. Okay, so for that, I just need to make a list comprehension. Okay, so I'm going to just create the column on our original data set. So our original data set, it was data frame or DF, and the name of the new column is going to be activity level, just like this one. So this is going to be equal. It cannot be equal to this because it's just going to take this and copy and paste this information. But we want to place this information, for example, this data, and match it with the ID. So every time this ID appears on our data frame, we want this column to have this specific info, okay, or this specific data. So to do that, like I said, I'm going to use a list comprehension. So for that, I'm going to use the variable I created, in this case ID activity level, which only has this column. Okay, so now I want to every piece of data, okay, or every every piece of data for C in the F ID. So I want each item on this kind of list or series, I want each item which is very active, okay, for and use it on every item on the ID column in our original data set. So that's what that's going to make or do. It's to pair the very active with the ID. Okay, so I'm going to run this, and after running this, we can check our original data frame. I'm going to say head, just 4, and we should have the activity level column. Okay, so we have it here, and it says that this user is considered very active. Okay, we have here our results, and now we can begin our analysis. So we did this, and we can also make this or do the same with the second category. Maybe it's not going. I'm not going to be able to do it because of the time, but we can follow with our analysis. So I'm just going to delete this, and okay, we already know the number of unique IDs. So in this case, so we know that it's 33, and just to make sure, oops, I'm going to use the n unique function. So we know it's 33, and also we want to know how many times these IDs appear on the dataset, because we know that the data spans from for a month. So if we say activity date also and unique, okay, so we have 31 unique days, and let's see if each ID appears each day. So to do that, I'm just going to see how many times each ID appeared. So it appeared 30, for example, this ID appeared 31 times. So we have data of all days, but there are some IDs like these ones. For example, this one we have only 4 days of data from him, and this one we have 18 days. So yeah, we know that now. And okay, we know what's the dates from which day to which day. We said April 12th and May 12th. Okay, that was the date. Okay, so now to analyze, we can begin by describing our data. So to do that, we can use the describe function, and what this is going to do is it's going to show us a summary of some groupings, some summaries just in general, and some statistics. For example, we can see the mean of all the steps for all users, and also the distance, and the minutes, and the calories. We can see the standard deviation, the minimum, and which is 0 in this case, and the percentiles. So we have the 25th percentile, the 50 percentile, the 75 percentile, and the max. Okay, for the steps. So this is the sum of all the steps, and this is the sum of the 75% of steps if we order them from high to, or from lowest to highest. And so okay, so we have here our data, and yeah, so we see, for example, for max, okay, we see here that someone walk for 28. It could be miles or kilometers, I don't know, but it's way higher, for example, than the 75 percentile. Okay, so, and also the mean. So here the mean and the 50 percentile are kind of similar. So someone walk a long distance. So this could be an outlier. So we need to pay attention to this. And also here, someone burn for one day 4,009. Oh, you cannot see it. 4,900 calories. So that's a lot. So that's the double of a normal healthy person burns each day. Okay, so we are supposed to burn like 2,000 calories, 2,000 and something calories per day. That's the calorie intake we need to take every day. So someone did this. So we have to take to pay attention to this. It could be an outlier because the mean it's 2,000. You can see like normal person burns 2,300 calories. And yeah, also the 75th percent or 75% percentile, it's kind of the same, 2,000 and something. Okay, so we know this, and now we can make some plots for our analysis. So now this is going to be the share step, or the share phase, in which we can now make some plots. So first I want to know the correlation between steps and calories burned. Okay, maybe we think that the more steps someone did, the more calories it burned, but we are not sure, so let's find out. So for that, I'm just going to make a plot. So I'm going to make a axis variable, and I'm going to use seaborn. So for making correlations, we can use the scatter plot, and I'm going to type here the x axis is going to be total steps. Oops. Total steps, and the y-axis is going to be calories, and our data is going to be our data frame. And yeah, by doing this only, we can already see our scatter plot. So you can see here that, yeah, it seems like a positive correlation. The more steps someone did on a given day, the more calories it burned. So someone did, for example, 3,000 steps, and it burned like 4,000 calories. Or yeah, there are some outliers, some people who didn't match the correlation, but most people, for example, they did like up to 15,000 steps and burned this. So this is for each day. Like, it's grouping everything. So, but now I want to color this using hue, and I now know the activity level of each individual. So I'm going to use that to see how it fits here. Okay, sorry, I did this wrong. Okay, and also I can put a title which is going to be correlation calories versus steps. And just to make it tight layout and dot show. Oops. Okay, now yeah, so we can see here where the different groups lie. For example, or fit. For example, here sedentary are the people who did less steps, so they burned less calories. People who were active, it's all scattered here, and people who were very active, you can see they burned more, they did more steps on average, but it's not always. So we know that, and yeah, now we can see the average. We want to know the average steps per day. Okay, we want to know if on Sunday people did more steps than on Monday or Tuesday or Wednesday. We want to know that. So for that, I just want to I'm going to create first. Okay, I'm going to just plot this. So I'm going to create a figure and axis, and I'm going to use the subplots function within matplotlib, and I just want one plot or a plot in one row, or the first row, first column. Okay, just one row, one column, and the size of this figure is going to be 8 and 5, just to give a number. Okay, so now what I need to do is to group by day the data. I want the steps for each day, so I'm going to create a new group. It's going to be df.group by and day of week. Okay, because day of week was the name of the day. So I need to take the average daily steps and I'm going to grab this group, specifically the total steps column, and I want the mean of that. And now I'm going to create a variable which is going to show us the mean of all the steps. So this mean, okay, it's going to only to show us this. So I want that. So total steps dot mean, and yeah, this is I'm going to use this to compare it against each day. Okay, if certain days people walk or did more steps above average, up or below average. And now I'm going to plot this using a bar graph. I want to plot the average daily steps and because this is the group, it's not a data frame, the day of the week is going to turn, or is the index in the group by. So I want the index as the x-axis, and I want the average daily steps as our y-axis. And so, for example, if I do this, oh, I have an error. Key error, day of week. Day of week. Okay, what's the issue? Oh, sorry. So, day of week. Okay, I don't understand. Okay, so it says day of week. We don't have day of week. So it was it different? So calories, sedentary minutes. Oh yeah, it says that we don't have the day of week column. Maybe it was because I didn't create this. Yeah, it's supposed we are supposed to have that on our data frame. Let's see. Oh no, we don't have it. Activity level, and we don't have our day of week column. Why is that? Oh yeah, because I created the columns, and then on the subset I didn't specify that I wanted these columns. Okay, so I'm going to rerun this. I want this, and now I want this, and I want to subset this data with this, and that's all. Yeah, we have the activity level, everything. Okay, so now we are supposed to have this. Oh, so what's the issue? Okay, day group is not defined. Day group. Oh, sorry. So we haven't defined that. So day group is not day group, is day grp. Yeah. So now we have here our graph. So we can see that, for example, on Monday, the average amount of steps was about 7,000. On Friday, sorry, and on Monday was this, on Saturday was this. So the problem here is that the name of the days are not in order. These are in order of on alphabetical order, but I don't want the alphabetical order. I want the order of the day. For example, Monday, Tuesday, Wednesday, Thursday, etc. So sorry. So to fix that, I need to set the ticks for each x-axis. So I'm going to use x_set.x_ticks, and it's going to be the range of the len of the name of the day of the weeks. So to make it easy, sorry, I'm going to create a list with the day of the week, or I could, for example, use the day of week, and oh, sorry, the distinct. I don't know if it's the distinct or dot unique. Yeah, so I can create this to list. Okay, maybe I can create a variable here. Day equals this, and I want this, and the first, oh yeah, okay, array to list. Okay, I cannot turn an array to a list. Okay, that's unique, and I want to show it this Tuesday, Wednesday. Okay, it's not in order again. So what I can do to make it simpler is just to create a new variable with the name of the days. So I can do this: Monday, Tuesday, Wednesday, Thursday. So it has to be in order. Friday, Saturday, and Sunday. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so I'm going to use that to replace the x-axis with these values, okay, in this order. So now I want to, we said here that we want to len of day of a week variable, this one, and also I want to set the labels as it's here. Oh, sorry. Okay, and we are supposed to have, okay, xtick labels. Oh, sorry, it was set underscore. Yeah, so now we have fixed this. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so that's good. So good so far. So far, so good. And now we want to create a line here where it shows the average. So to create that, I'm going to use ax h line, which is an horizontal line. The y value is going to be this, and also okay, the color, I need to specify a color which is going to be red or blue in this case, and the label is going to be average daily steps. I also want to set the y label and the x label, the name, just to make it more clear. So y label is going to be steps, and x.set x label is going to be day of week, and the title of the graph is going to be average number of steps per day. Also, I want to show the legend, because for example, if I do this, okay, it doesn't show this. Maybe if I do this, oops, yeah, okay, so now we have here the line, but it doesn't tell us what it means. So I just need to show the legends and show the graph. Okay, so we have our graph here. I'm going to zoom out so that you can see better. So we can see the average number of steps per day. So you can see that on Thursday, people took less steps, and on Saturday and Wednesday, people did or walk more. Okay, that's interesting. And on Sunday, they walk below the average. So that's interesting already. So yeah, Thursday and Fridays are lazy days, or lazier than the other days. And Wednesday is the more, and Saturday are the most active days of the week. Okay, so we know that. And now we can show what is the percentage of activity in minutes, or we can just skip that and see the correlation between for example, minutes Okay, no, I'm going to show you everything. Okay, I'm going to show you the percentage of activity in minutes. So what's the percentage of time people are active? So I can say, hey, say here, percentage of activity in minutes. Okay, so for each day, what is the percentage? Okay, how many minutes or how much time people are being sedentary, or how much time are people being active or very active? So we want to find that. So for that, I'm going to just sum everything. I'm going to so I'm going to make this a very active minutes, which is going to be, sorry, the sum of this, and the same for the other column. So I have the code here, so I'm just going to copy and paste. Oops. Okay, so it's going to sum everything, and with that information I want to create a pie. So the slices of our pie are going to be the names of the are going to be this information, these variables. So the first one is going to be this, the second one is going to be this one, the third one is going to be this one, and the last slice of our pie is going to be this one. And I also want the labels, okay, because if I don't specify the labels, it's not going to show us. So so I'm going to just copy and paste also this, to make it simpler. Okay, because we are already hitting the 1 hour and 40 minutes mark. And I also want it to explode. So explode, it's just to separate the slices. So the first slice not going to separate, the second slide is not going to separate, the third one no, and the last one, the fourth one, is going to separate just a little bit. And now I need to create the pie graph, which is with plt.py. The slices are going to be the slices variable. The labels are going to be the labels variable. And also the explode is going to be explode. And okay, let's see how it looks. Yeah, so we have here our graph. Maybe we can show more information, for example, the percentage. So to show the percentage, we have to use this function, autopct equals, and we have to do this. I don't know why specifically, but it's just how it is. And I also want, okay, maybe that's everything I want. Yeah. And I just want a title as well. The title is going to be percentage of activity level in minutes. Okay, percentage of activity level in minutes. And I just want to show so that, okay, looks better. Okay, so here we have that 81% of the time people are being sedentary. 15.8% of the time people are being lightly active. 1.1% are being fairly active, and just 1.7% people are being very active. So the majority of time people are being sedentary. This could be explained also if the device is tracking the activity level at nights. Okay, so this is not so how to say it, it's not fair only to say that people are being lazy, because most of the time we are either sleeping or I don't know, sitting down or something. But here you can see it's just a perspective. So lastly, what we can do is that we can't so before we hit the 2 hours mark, we can make a correlation between the activity levels and the calories to see if people who are active burn more calories than people being sedentary, and etc. So let's see. Okay, so for this I'm going to graph correlation between activity level in minutes and calories. Okay, so I'm just going to create a list of day of the week. So it's going to 0 to 1, 2, 3, 4, 5, and 6. We already know what that means. I'm going to create a figure and axis because I want multiple graphs in this code of block of code. So those are subplots. So it's plt.subplots, and I want the number of rows are going to be 2. The number of columns are going to be 2 as well. So we are going to have 4 graphs, and the size of this graph is going to be maybe we can say 8 and 9, and dpi equals 70. Okay, this is just like zoom. So I'm going to use the scattered plot from Seaborn, and the data is going to be from the data frame the X values are going to be calories, and the Y values are going to be these sedentary minutes. The hue or the color of the dots is going to be the activity level, and I want to place this on the first row. Okay, the first row, first column. First row, first column, and I don't want a legend to appear. Okay, so if I show this, okay, so we have here 4 graphs. The first one is populated because I specified what I wanted to do, but the other ones are empty. So to populate this, I just need to copy and paste this 3 more times. 1, 2, 3. And I just need to change the values. The Y values are going to be now lightly active minutes, and I want this on the second row. No, sorry, second column, the first row, and on this one. And I want this to be from the fairly active. And I want this on the second column. Sorry, second row. And this is going to be very active. And I want this on the second row, second column. And I just want to tell people what the colors of the dots mean. So I want dot legend to show the legend, and maybe I can specify the title, which is going to be activity level. Oops, activity level. And okay, if I do this, okay, could not interpret. Okay, varied. I had a mistake here. Very active minutes. Okay, so the legend is not showing. Okay, maybe it's because we specify false here. So if we say true, maybe for only one of those, it's going to show. But we want to show only one because we don't want to repeat the legend on every single scatter plot. So to do that, we can move this legend outside of the graph. So to do that, we can do the following, which is going to be here on legend. We can say be box to anchor. Oops. To anchor equals, and I have to specify like on the like an imaginary axis here. I need to specify where in this axis is going to be located the legend, or the legend is going to be located at. So this maybe this is going to do. Okay, yeah, so it's here. Maybe if I change here, yeah, that's a little bit better. It's doing this, it's by trial and error. It's not that I know exactly in which number it's gonna fit better. It's just you need to try. But now I just need to make it a little bit bigger. So I'm going to specify the title, the font size. So font size is going to be equal to, I don't know. Also, this is going to be trial and error. And the title font size, it's going to be maybe 18. Okay, let's see. Yeah, it looks better, but I just need to move this away a little bit more. Yeah, so we have here, maybe if it's lower, it's going to look better. Yeah, what about 1.7? Okay, so much better. So we can see here the scatter plots. We can also make a title for this. So I'm just going to copy and paste the title because I have the code here. It's going to be with this subtitle, and then I'm just going to show this so it's looks better. Okay, so I have here the scatter plot, and we can see here, for example, if I zoom in, oops, what happened? Okay, so we can see that for the sedentary users, okay, so the minutes the people were sedentary, they burned not so many calories. So yeah, they spent a lot of minutes being sedentary, and they did this. So for example, so we don't have like a correlation. The more minutes, it didn't equal more calories burned. Actually, maybe a little bit the opposite. The less minutes they spent being sedentary, the more calories they spend. Okay, and the opposite happens with the lightly active users, or sorry, the lightly active minutes. So the minutes the users were lightly active. So the more time they were lightly active, which we don't know exactly what that means in numbers, they spent more calories. Okay, so here we have a positive correlation. So when they were fairly active, again, the more minutes they spent doing it, they burned calories. But here we don't have like a correlation per se. For example, some people, it didn't matter if they spent like an hour or 2 hours being fairly active, they burned the same amount of calories, like 1000 or 1800 or something like that. But what about the minutes they were very active? So here we can see also like a positive correlation. The more minutes they spent being very active, the more calories they burned. And also we can see that the minutes, or the people who were spending more minutes being very active, were the people who are very active. So we can see here the red dots. Okay, they concentrate over here because they were the people who spent more time being very active. So we are just confirming what we know. And yeah, so this is our analysis. You can see we made 3 graphs. Okay, most of the time we spent the most on cleaning the data, preparing the data, creating columns. So on a daily basis, that's what it's going to take the most time to prepare the data. And the graphs are fairly easy. Once you have cleaned the data, prepare the data, processed, creating columns, checking for null values, grouping the data, etc. So Now we can go and tell the stakeholder, we can make conclusions, the differences between the type of the users, what's their behavior. So we already know that, for example, some days they are being more active than other days. We only missed the group by the minutes of usage of the devices. That's also, it's going to help. If we want to make a deeper analysis, so I encourage you to also do that on your own. Leave on here down here in the comments, what do you think about this project? If you have already done it, if you are making, I don't know, the Google Data Certificate on your own, or if you are studying for being a data analyst, if you have experience with pandas or NumPy or Python in general. So that's going to be very interesting to read. And yeah, so this is our analysis on the Bellabeat case study for the Google Professional Certificate. So thank you so much, and don't forget to subscribe.